Hi everyone and welcome back. Now it is time to pre-process our data. As mentioned in the lecture, we at first crop 32 pixels from top and bottom. Next, we set normalize and standardize per subject to finally save the individual 2D slices as NPY files. To start with, we create two helper functions for normalization and standardization. At first, we create our normalize function. Let's call it normalize, which accepts the full volume. We compute the mean mu by calling full volume.mean and the standard deviation by using np.std, to which we pass our full volume. We now set normalize this volume by at first subtracting the mean, followed by division by the standard deviation. Last but not least, we return the normalized volume. Next, we define our standardization function, called standardize, which accepts the normalized scan. We perform min-max scaling by at first subtracting the min value of the scan from all pixels, followed by division by the difference between the maximal and the minimal values. Of course, we return the standardized scan afterwards. Let us define a variable called all_files, which will take the paths to all subjects. We can use root.glob with the identification string LA* again. Let us quickly check the length of this list to make sure it contains 20 paths. Alright. We can now start to code our pre-processing cell. To begin with, let us define our safe route. We could use a directory called preprocessed. Next, we code the loop over the paths to all MRIs. We use enumerate to get access to the loop counter variable and tqdm to get a progress bar. Within the loop, we at first define the path to our label mask by leveraging the helper function we defined above. Next, we load the cardiac MRI and store it in a variable called MRI. Let us now write an assertion to make sure that our current MRI scan has RAS orientation by using again nibabel.affine to Xcodes. Afterwards, we extract the array from the nifty file and store it in MRI data. Additionally, we load the segmentation mask, directly extract the NumPy array, and convert it to an integer. Subsequently, we crop 32 pixels from top and bottom, plus 32 pixels from left and right. We don't crop along the viewing axis. To do so, we override our MRI data variable and use multi-dimensional slicing. We extract all pixels starting from 32 up to -32 along the first and second axis. We of course have to perform the same operation for our label mask, as otherwise slice and label would not fit anymore. After that, we normalize the MRI data with the help of our normalization function and store the result in a variable called normalized MRI data. Based on this result, we use our standardization function to standardize the scan. Last but not least, we have to check whether we're in the train or the validation split. As we want to use the first 16 or 17 subjects for training, we simply check if the loop counter is smaller than 17. If that is the case, we define the current path as safe route / train / the loop counter converted to a string. This means that we create a separate directory for every patient. In contrast, if our loop counter is 17 or above, we're in the validation split. Thus, we replace train by val. Perfect! Now we are ready to loop over the single slices of the current scan and store them together with their corresponding segmentation map. We now loop over the range of the last axis of our standardized MRI scan to extract at first the current slice from the standardized MRI data. Additionally, we grab the corresponding slice from our current label data. Next, we create a safe path for the slice and segmentation mask by appending either data or masks to the current path variable. We now use the mkdir function to make sure that both slice path and mask path exist. As usual, we pass parents equals to true and also exist OK equals to true. Last but not least, we use numpy.save to store the current slice and mask in their corresponding directories with the inner loop counter variable I as file name. Alright, let's run this cell to pre-process our data. It should only take a few seconds. Let us now take a look at the pre-processed files to make sure everything worked. At first, we define the path to a subject. Let's use preprocessed train 0. Next, we choose a single file and load the corresponding slice and mask. Let's say we want to use as an example file number 50, therefore we write 50 and directly add the file extension .npy. Next, we load the slice by using numpy.load path/data/file. To load the mask, we use numpy.load path/masks/file. We will now finish this lecture by plotting this particular slice with the mask laid on top of it. To do so, we again create a matplotlib figure. At first, visualize our current slice with the bone color map. Create the masked array next by using numpy.ma.masked_where with the task of masking all elements which are 0 in our mask. Last but not least, we use plt.imshow one more time to visualize this mask with again some transparency. Alright! Congratulations! The pre-processing step is done. Nice! In the next lecture, we will create the dataset. Thanks!